Alright, good morning, ladies. Unfortunately, the little one was sick today, so I was unable to come to school, but I thought I'd give something a try. This may or may not work. You may find it helpful, you may not. But I thought, why not? Let's give this a try. So, anyway, what we're going to do here is I'm going to kind of talk you through the lesson via webcam, and hopefully you find it helpful. You can view it as much as you want, or as little as you want. If it annoys you, I apologize for that. But anyway, I thought this might be a good try, or good something to try to see if we can't get through the section without me actually being there. So for those of you who want to know, we're going to be looking at section 6.4, which again looks at graphing, but we're going to look at the transformations of the sine and cosine graph. Now, in order to do that, we're actually going to kind of go back to what we did a little bit in September. And if you remember, when we were dealing with conic sections, this was the equation of a circle. And I don't know if you remember, but h and k, those two variables indicated which direction the center of the circle would shift. So if you remember, h was the shift along the x-axis, so that was left and right, and then not y but k, that was your y-axis shift, and that would move your figure, in this case the circle, up and down. So if I was going to put the circle over here, this would be the new center, and it would be at some coordinate h comma k. So notice the circle didn't change at all, but when you shifted it, it was just a different location, same shape. We're going to basically be doing the same thing with the trig graphs that you guys have been working on for homework, and a little bit of what we did last semester. So let me kind of we'll take kind of a little look at that and see what that ends up looking like. So we're all used to seeing a sine bx and also a cosine bx, and from there we were able to come up with the amplitude, which was the absolute value of a for both of them, and the period, which to calculate that we would take 2 pi over b for both. So that's what we've done so far, and that there's no shifting in the graph. There's no shifting in the graph here. So we want to now look at what happens and how these graphs shift, which that brings in the h and the k. Okay, whenever you see h and k in an equation, that means the graph is going to shift at some point. So what is the question then is, well, what do these equations look like with h and k in them? Well, they both look similar. You can put these in, and they basically do the same thing to both sine and cosine. So if you had a sine of b, so notice that part hasn't changed, but this is where it changes. You may get parentheses x minus h and then plus k. And cosine's the same thing. You get a cosine b x minus h plus k. And both of these would in turn be equal to y. So this is what the new equations would look like. And just like, I'm going to scroll down a little bit, just like it with the equations, the equation we used up here with the circle, if you recall, if we go back up to the circle, the h and the k are a part of the equation, and they move, in this case, the circle left and right for h and up and down for k. So if we come back to the trig equations, then h and k do the same thing to our trig equations. Right? So now, in addition to finding the amplitude and the period, you are now going to also need to be able to identify h, which is the shift left or right, and k, which is also a shift, but that's going to be up or down. Okay, so you're going to need to be able to identify those four things. So let's take a look at an example. I'll put a easy little example over here. So right now we're not graphing anything. We're just going to identify these four things. So let's say y equaled 3 sine 2x minus pi over 2 plus 4. So that's going to be the new equation. It looks a little bit more complicated, but there's just a few more extra little parts in here. So again, the amplitude is still this first number, which is in this case is 3. So the amplitude is going to be 3. The period, remember to calculate that, we need 2 pi over b, and in this case b is 2, so it's going to be 2 pi over 2, which becomes pi, right? Then now 3, we're going to use h. Okay, so we want to look for the shift left or right, which if we come up here and look at our equation, x minus pi over 2, so again, just like with the conic sections, we take the opposite here. So for h, that's going to be pi over 2. And then for k, the shift up or down, we're going to look at 4. So k would be 4. So all this means here is the amplitude of the equation is 3, or the graph is 3, meaning the height of the graph is going to be 3. The period that we're going to look at has a length of pi. The graph itself is going to shift to the right pi over 2 because it's positive. If it were negative, we would go to the left. And k, it's positive 4, so that means we are going to go up 4. And as I said, we are going to go right pi over 2. Right? So those are the basics of using these equations. I want to show you one more example, and if you have questions or if I went through this a little too quickly, just the beauty of this recording is you can just replay it and listen to it again, and hopefully that will help explain a few things, and then you can apply it to a couple of the problems on your homework. So let's take a look at one more example. We'll kind of do something along the same lines here. So let's say we had, make sure I get it on the screen here. Say we had y equaled, I don't know, 2 cosine, let's see, 5 x plus pi minus 4. Right, so we'll take a look at this one, and we'll do another example. There's one more thing I want to show you. So again, we just want to find those four things. We want to find the amplitude, which I'll let you see if you can do here real quick while I wait. Kind of write some stuff down. So if you haven't figured it out, the amplitude is this first number, again, 2. The period is going to be 2 pi over b, which in this case is 2 pi over b is 5. And then I'm going to let you work on h and k real quick while I write one more example down here. So coming back up here to h, if you didn't figure that, h is pi, but we take the opposite, so it's going to be negative pi, meaning that we're going to go left, in this case, a distance of pi, and then k is going to be, in this case, we don't have to take the opposite because it's outside the parentheses, so it's negative 4, so that means in the end we're going to shift the graph down 4. Right? So hopefully it's not too complicated. There's not much calculations going into it. The only calculation you really have to do is in the second step to find the period. The rest of it's just identifying the different numbers. So I have one more example to show you. This one's a little bit different. Again, I'm going to let you kind of look it over, write this down, and see if you can note the difference between this equation and what we've been doing up here. Alright, so those again, 4 things we need to find. Amplitude, okay, well that hasn't changed, that's still 3. Now the period, this is where it gets a little tricky, is if you look with this problem right here compared to this one up here, there's a 5 in between the cosine and the parentheses. Notice there's nothing here, which most people might say there, well it's 1 then, but if you look inside here, notice this x has a 4 on it. And for our standard equation of sine and cosine, we don't want that 4 in there. We want x like it is up here all by itself. So in order to get this 4 out, I don't know if you guys remember, but essentially what we need to do is we need to then factor that 4 out. Okay, it's not complicated factoring, we just essentially divide everything here by 4. So then our new equation becomes the 3 stayed the same, so sine. Now because we pull the 4 out, that 4 is going to go on the outside of the parentheses, and 4x divided by 4 is just x, minus 4 pi divided by 4 is just pi, and that plus 1 is still the same. So now our equation here is just it's just the same. Okay, now it's exactly like that, and we can pull out the rest of this without too many problems. So our period is 2 pi over b, which in this case b is 4. So we reduce that and we get pi over 2. Then our h is inside here, so that's minus pi, so we take the opposite, so that would be pi plus 1, that. And we've got our 4 crucial parts to our graph. So I'm going to let this recording stop now, and you can work on the first part of the homework, which is just literally finding these 4 things for the problems that are on Edmodo. So you'll just have to look at Edmodo, and the description of the homework is just right below, I think, the link or the post that you clicked on for this video. So if you have any questions, maybe watch the video again, see if you can't figure it out. And once you've worked through that and you feel pretty confident here, go ahead and watch the next video that I've attached, and that's going to actually show you how to use this stuff here to graph what we found. All right, we'll probably just end up graphing these specific examples, or maybe a couple new ones, but it really doesn't matter because it's all the same. So go ahead and work on those assignments, and if you have any questions, again, watch the video again, or see if you can find somebody in class who might have some help or might be able to give you some help. I should be in class on Friday, so you can track me down during academic support. All right, thanks, girls.